Hi students, now in this video lecture we will start with a new chapter, metallurgy, right? It's metals, non-metals and metallurgy. And what is metallurgy? Metallurgy is basically extracting metals from their ores, right? And what are ores? Ores are minerals which contains metals in the combined state, right? And for example, we extract aluminium from its ore bauxite, right? So bauxite is a mineral which contains metal aluminium in the combined state. And what is metallurgy? Metallurgy involves all processes, right, or methods using which we extract this pure metal from its ore, right? Because metal is present in combined state in the ore and it contains many other impurities. So removing all those impurities, right, using different processes, metallurgical processes, is metallurgy. Now let's talk about metals and non-metals. Metals and non-metals are elements, right? And we know in periodic classification that total elements that are known, that are discovered, are 118 elements, right? And all these elements are distributed in earth crust, right? And we have a metal which is, this question has been asked once, name the metal which is most abundantly found in earth crust. That is, it's aluminium. Aluminium is the metal that is most abundantly found in earth crust, right? And we have non-metal elements like oxygen. Oxygen is present in air by a percentage 46.6% around, right? And now these 118 elements, right, we know there are 118 elements, right, and all these elements are divided into metals and non-metals, right? And for metals, for non-metals, we know there are only 22 non-metals. From among these 118 elements, only 22 are non-metals, rest are metals, right? And we need to remember one thing, that all metals are solids, right, except one, which is mercury. Mercury is a metal which exists in liquid state at room temperature, right? For metals, this mercury, the formula of mercury is Hg. Mercury exists in liquid state, right, at room temperature. So mercury is the only element that exists as in liquid state at room temperature. Now if we talk about non-metals, among non-metals, 11 non-metals, out of these 22, 11 are gases, right, and rest are solids. Only one is liquid, which is bromine, right? So we have 11 non-metals are gases, right, and there's only one non-metal which is liquid at room temperature, which is bromine, right? Bromine is the only non-metal exist in liquid state, right, and rest are solids, right? So this is important. Name one non-metal that exists in liquid state at room temperature, it's bromine. And name one metal which exists in liquid state at room temperature, it's mercury, right? This is important. This has been asked before. And for metals, we know that metals have been known to mankind since very ancient times. And the first metal that is known to mankind from very old times is copper, because humans have made utensils and weapons out of copper, right? So copper is the element or metal that is known to mankind since long time, right? So we write it as copper is known since ancient times, right? And there are other elements or metals that are known to mankind like lead, mercury, gold, silver. All these metals are known since very old times, right? And there are various uses of metals. Metals are used to make in heavy machinery tools, right? They are used in making utensils, right? They are used in making various kinds of objects that are used in construction, right? They are used in building constructions, and they are used. Gold, gold is a metal. Silver is a metal which is used to make jewelry, right? They are also used to make coins. Like this, there are various uses of metals. Similarly, if you remember the previous chemistry, metals have been used as catalyst also in various reactions. Like iron has been used in catalyst, right? In various reactions, molybdenum has been used as catalyst, right? All these are metals which are used as catalyst, right? And iron is there are some metals that have biological importance as well. Iron is a metal which is found in our blood pigment called hemoglobin, right? And it is through iron which carries oxygen in blood, right? So iron is a metal which is found in blood pigment called hemoglobin, right? Similarly, magnesium is found in plant pigment, right? So all these are small things, but just remember, because these small things may be asked in exams, right? So if we talk about hydrogen, we are studying metal and non-metal. Now if we talk about hydrogen, is it a metal or a non-metal? We know hydrogen has a dual nature. It can act as a metal, it can act as a non-metal. But in periodic table, if you see, hydrogen is placed with alkali metals. Why? Because same as alkali metals, hydrogen can also lose its outermost electrons, right, to form a cation, right? So I'll write it over here. Hydrogen has a dual nature. Since it acts as a metal and a non-metal, right? It is placed with alkali metals in group 1 of periodic table, right? Since like alkali metals, it forms cation after losing one electron, right? And similarly, it can also behave like non-metals, right? Because we know hydrogen has one electron in its outermost shell, so it has a tendency to receive one electron, right, to complete its octet, to complete its doublet, right? Because metals or elements, after acquiring 2 or 8 electrons, will become stable, right? So hydrogen can lose electrons like metals, and it can accept electrons like non-metals like chlorine, bromine, iodine. We know that chlorine has 7 electrons in its outermost shell, and it can receive 1 electron from another non-metal, from another metal, to form a compound like sodium chloride. So chlorine receives 1 electron from sodium, right, and it completes its octet by receiving 1 electron from sodium, right, and it forms a compound sodium chloride with sodium metal. Similarly, hydrogen can also form a compound with sodium metal, right? How? Hydrogen has 1 electron, it can receive 1 electron from sodium, forming sodium hydride, right? So it acts like metals, like non-metals. It can receive an electron, forming a compound, electrovalent compound like sodium chloride, right? Sodium chloride is a compound where chlorine is non-metal, right? Similarly, we have compound called NaH2, sodium hydride, or I think NaH, it's sodium hydride, right? Wherein one hydrogen atom reacts with sodium atom to form sodium hydride. So here it's acting as a non-metal like chlorine, right? And so this is about hydrogen. Remember its dual nature, it can act as a metal as well as a non-metal. And why is it placed with alkali metals? You need to know the reason, right? And there are various uses of metals like hydrogen. Hydrogen is used as a fuel, right? And hydrogen is also used in hydrogenation of vegetable oils. Vegetable oils are hydrogenated, right, to make vegetable ghees, right? Oils are converted into ghee by hydrogenation reaction. In hydrogenation reaction, what we do is we react oils, which are organic compounds, with hydrogen. So hydrogen reacts with vegetable oils, giving you vegetable ghee. So this is one important use of hydrogen. And it is also essential part, hydrogen is also essential part of various organic compounds like proteins, enzymes, right? Carbohydrates, lipids, all these contain hydrogen, right? So let's just recall one more thing. Metals and non-metals. We know that metals have 1, 2 or 3 electrons in valence shell, right, which they can lose, which metals can lose, forming positive ions, right? So metals can lose electrons, forming cations, right? Similarly, non-metals have 4, 5, 6, 7 electrons in valence shell, right? So they can gain electrons, forming anions, which are negative ions. Like if M is a non-metal, right, it can gain an electron, forming M minus, which is an anion, right? So metals form cations by losing electrons, and non-metals form anions, gaining electrons after gaining electrons, right? So this is important. And one more thing, we have done this in periodic classification, that the number of electrons gained or lost, here number of electrons gained or lost is called as valency, and valency is the combining capacity of an element, right? We say it as a, since sodium, for example, if we take as sodium can lose 1 electron to form sodium ion, so we say valency of sodium is 1, right? Since it can lose 1 electron, right, so it can give this electron to some other element, right, combining with it. So it will combine with one atom of a non-metal. It can combine with, like, if it will lose this electron can be gained by chlorine, right? So one atom of chlorine will combine with one atom of sodium to form sodium chloride. So we say combining capacity of sodium is 1. It's combining with one atom of chlorine, which is its valency. So valency is the combining capacity of an element, and it is also number of electrons gained or lost. Number of electrons gained by chlorine is 1, lost by sodium is 1, and the valency is 1. So now these metals are further divided into alkali metals, alkali and alkaline earth metals, and transition elements. Right, here we will concentrate on alkali and alkaline earth metals. We know in periodic table alkali metals are part of group 1, right, and alkaline earth metals are part of group 2. Since alkali metals are part of group 1, that means by group 1 we mean all alkali metals have group 1 means 1 electron in their outermost shell. Similarly, alkaline earth metals like calcium, magnesium, strontium, barium, all these exist or lie in group 2 of periodic table. Group 2 means 2 electrons in their outermost shell. We know that magnesium, calcium, barium, all these elements or metals have 2 electrons in their outermost shell. Similarly, if we talk about alkali metals belong to group 1. They have 1 electron in their outermost shell, right? Sodium, we know that sodium has 1 electron. Sodium, lithium, all these metals have 1 electron in their outermost shell. So we say alkali metals belong to group 1, right, and alkaline earth metals belong to group 2, right. So all these have all alkali metals have 1 electron in their outermost shell. Alkaline earth metals have 2 electron in their outermost shell, right. And one more thing which is important, we will see the reactions of these alkali metals and alkaline earth metals. First, we need to see why we call it as alkali metals and why we call these as alkaline earth metals. Alkali metals react with metals forming alkalis, right. Alkali metals react with metals forming alkalis. We know what are alkalis. We have studied in acids, bases and salts. Alkalis are water soluble bases, right. So alkali metals react with water forming alkalis. So they are known as alkali metals. That is why they are known as alkali metals, because they react with water forming alkalis. Similarly, alkaline earth metals. Why we call it as alkaline earth metals? Because all metals that come under alkaline earth metals are found in earth crust, right. So from there we have taken the word earth, and alkaline because they also react with water forming alkalis, which are water soluble bases, right. So alkaline earth metals, they are found in earth crust, right. They are found in earth crust. They are found in earth crust and form alkalis with water, which are water soluble bases, right. And all alkaline, then there are some comparisons like alkaline earth metals and alkali right. So here we have small comparison. These alkaline earth metals, they react with water, giving you hydrogen gas, right. And alkali metals are more reactive compared to alkaline earth metals, right. And they react with acids, again giving you hydrogen. So same as here, they also react with acids forming hydrogen, and they have ionization energy. They have low ionization energy, right, and they also have low ionization energy, right, but more than alkaline earth metals have ionization energies more than alkali metals, right. And both these metals are highly reactive, right. So we are done with this, right, almost. And these alkali metals, these are soft, right. Sodium metal is a soft metal, right. And one important thing, both these are obtained by electrolysis of their molten salts. This is also obtained by electrolysis of molten salt. Why electrolysis of molten salt? Because these are, we have already discussed this before in electrolysis, and because these metals, alkali metals and alkaline earth metals, are more reactive than hydrogen, right. In the electrochemical series they are above hydrogen, right. So in the electrochemical series, if instead of their molten salts we take their aqueous salts in electrolysis, instead of metal we will have hydrogen obtained at cathode. So metal would not be obtained, only hydrogen would be obtained. So that is why we say we will always take these salts of these alkali and alkaline earth metals in fused state, in molten state, so that we can obtain metal at cathode, right. If we take aqueous salt of these metals, we will get hydrogen, right, because hydrogen is below in the electrochemical series, so will preferentially discharged, right, compared to these metals. So this point is important, right. And just go through all these points what we have learned, right. These points are really important. Just remember the exceptions: mercury, bromine, right, and lead. Mostly metals. One more thing, mostly metals have shiny appearance, but there is one metal which have a dull appearance, which is lead. So lead is a metal that has dull